In this section, we're first going to talk about the different types of mixtures that are relevant in chemistry. There's three of them, but we're really only going to focus on one after this section. So the first one, which ends up being the most important one, is solutions. So solutions, real simple. It's a mixture of two or more substances that end up being at what we call in a single phase. So we have a solid and a liquid, but when we dissolve them, mix them all up, it stays a liquid. We take two solids, we mix them up, the whole thing stays a solid. So it can't be homogeneous if we have a solid sitting there mixed with a liquid. It's got to be one phase. That's the key phrase. Couple terms here. If you see the word soluble, solute, or solvent, this is a good way to just keep these straight. If we've got the word soluble, that just means that chemical can be dissolved. Solute is what gets dissolved. So for example, if we're talking about salt and water eventually, salt would be considered the solute, what gets dissolved. And the solvent is what does the dissolving. And a common phrase that we hear is water is a universal solvent. So on the bottom of page 402, they show some different types of solutions. And briefly mention these in class. You could have a solid plus a liquid plus a liquid, a liquid plus a gas. There are all different combinations of solutions that exist, some more common than others. The one you do not see up there is a solid and a gas. Okay? That's the one that's difficult to have. Okay? So you kind of read through that and see what those are. And we'll talk more about them in some of our labs that we do. The other two types of mixtures, which are not homogeneous, are suspensions and colloids. Suspensions, those are kind of the normal things we think of, like oil and water. We shake it up, it stays mixed for a while, but eventually it separates. A jar of M&Ms aren't going to be evenly mixed. Colloid is the same thing, except the colloid's kind of tricky. It actually does look like a solution. The only way we can tell that something is a colloid and not a solution is what's called the Tyndall effect. And the Tyndall effect is a test where you shine a light through a material, and if you see the particles deflect, then off of that, sort of like a laser beam and dust, then you know you have a colloid, okay, and not a solution. And again, you can little paragraphs on that on page 404. Okay. There's a couple other tables that just talk about the differences. What are some examples of colloids? What does the Tyndall effect mean? And then finally, some of the properties and characteristics that differ the three types of mixtures. After this section, again, really, we're just talking about solutions. We're not going to be talking about colloids. We're not going to be talking about suspensions. As we do chemistry labs, we take a solid, we dissolve in water, it stirs it up, mixes it, and we've got a liquid. Colloids and suspensions are very important and very useful. It's just not something that we are going to spend a lot of time with in this section. What we'll be moving on to next is just about solutions, how to make them, what their properties are, and then be able to make some measurements on them also.